Hello everyone, welcome to Show Me the Money, the Economics of STC Ratings.
This webinar is sponsored and presented by PABCO. My name is Tao Nguyen, AWCI's Education Program Manager. At this time, I'd like to welcome our presenter, Mike Amaral. As a QuietRock product manager of PABCO Gypsum, Mike is focused on educating the AEC community on acoustic solutions that meet design's goals. Mike's strong finance background led him to become one of the founding members of Quiet Solution, Inc., the high-tech startup that invented and patented the first sound damp gypsum panel. So welcome, Mike.
Thanks, Tao. Welcome everybody. So this is the Show Me the Money course. This is all about the economics of STC-rated walls. And just so you know, I am, again, I'm Mike Amaral from PABCO Gypsum. I'm the QuietRock product manager. And, I started my career off in the world of finance and found myself in building materials, still within the finance role, and then eventually into sales and product management. So it's been kind of a whirlwind tour here of going through the process of changing career paths and learning new businesses, and it's been absolutely fantastic. One of the things that this presentation began its life as an architectural presentation for continuing education, so that required a 1-hour course and to be brand agnostic. But in this environment, I don't need to be brand agnostic, so we can talk about QuietRock as we do. And I've also pared the deck down quite a bit to fit into the time constraints that we have, but I still have a lot of material to cover, and I'm gonna kind of zip through a lot of stuff. So bear with me if I go a little too quickly, but we'll have time for some Q&A at the end. So as we talked about, QuietRock is the first constraint layer damp gypsum panel. CDL panels have been on the market now since we introduced it back in 2003. Within the QuietRock sphere, we have multiple different options ranging from 1/2 inch to 5/8 type X to a radio frequency board, all the way to our low frequency board, which is 1 inch and 3/8 thick. Our 5/8 type X easy snap board is the most popular of all the products. It's about 80% of what we sell. We've got tons of published acoustic tests. We've got about 200 published in our latest edition of the Sound Design Guide, which I think we'll have a link to that at some point at the end of the presentation. And we are distributed throughout the US and Canada. And this is just kind of a lineup of our product portfolio, so you can see kind of visually what we have here. 510 is our 1/2 inch, easy snap, 530, 545. Some of those products, I'm sure those of you that have dealt with QuietRock have been familiar with those. So today we're going to go through a couple of different things. We're going to learn, some of the best practices on how we can achieve STC-rated walls, and we're going to discover, how small changes in the design process, while you're value engineering or trying to get the biggest bang for the buck, those small design changes can have an impact on your STC performance, and we'll kind of look at some examples of that. We're going to deepen our understanding of the current costs associated with designing and building STC-rated partitions and that interconnection between cost and environmental impact and what a true economic look at a sound-rated assembly is. So we're going to start off with a quick polling question. So how often have you ever been faced with building a high STC-rated wall? And I think Tao's going to put up a screen for you and open that poll up. So go ahead and quickly answer the questions. Give us a clue here. Great. Do we have results already for that one?
Yes, so 15% says rarely or never, 35 less than 25%, the other 35% says 25 to 50%, and 15% says more than 50 of the time.
Great. So good number of you are working in this space, so that's great to hear. So you'll be very familiar with what we're going to talk about. So next polling question is, what are the types of buildings that you're finding the need for these STC-rated walls? And I'll open up that poll for you. So, single family residential, multifamily, hospitality, healthcare, or other commercial. And other commercial, I guess you can throw in, institutional, education, that kind of thing down there in E.
All right, so we have 8% for single family residential, 35% for multifamily, 8% hospitality, 23% healthcare, and 27% in other commercial.
That's great. That's a really good broad stroke. So that's really nice that we've got a lot of different types of buildings that we're going to be talking about today. That's great. So let's first address the current economic climate. We're going to do just a very quick overview. We're going to start with steel. So those of you that are in, the commercial space, steel's a big problem with the changing prices. Tariffs are a reality that we're all having to deal with right now. And also, the supply chain interruptions, the fluctuating global demand is a huge effect on pricing. And also the regional impact, what is the impact of regional pricing and, the risk management on budgeting. So I've got a small chart here, and this is two different companies. This is Nucor and Cleveland-Cliffs, and they're both dominant players in the US steel industry, and they have conflicting pricing strategies. But you can see since April 2025, regardless of their pricing strategies, they both agree on one thing: steel prices are going up, and it looks like they're going to continue to go up for the foreseeable future. With obviously some little blips as markets and demands change. So there's one reality we have to live with is steel prices are going up, and we can always look at the price of wood as well. And wood, same situation. The wood pricing is fluctuating like crazy and is also on the upswing. Another reality we have is alternative drywall products. There's a trend for more innovative products, lightweight products, specialty products such as QuietRock, where we've got special purpose products. But with all these special purpose products, you have a price premium. So you're paying for that extra performance. So I kind of like to say that if the traditional commodity type X board could do what these special purpose boards do, we wouldn't need the special purpose boards. But there is a purpose for them. There's a reason, and we have a price premium for those because we're getting extra benefits, and it's actually helping us save money because we're not having to do a lot of things to make a commodity board do something it was never intended to do. And the other big thing we need to look at and address is the labor market considerations. When we're looking at walls, we tend to look at the materials that go into the wall, and we forget about the reality that all those materials need to be installed. And it is a significant cost portion of the installed cost of a wall. So let's look at a couple of different markets here. So we're going to start off with a very high labor market compared to the US norm. So this is New York City, and we're looking at labor rates for both open and union jobs. And you can see that the union wages are topping out around about $1.27 per square foot. Now this is the price of installing type X board on studs, no finishing. So this is purely installation labor. And you can see that it's been going up a little bit, but nothing dramatic. There's no like big heavy swings when we look at New York. Now we're going to go to Kansas City, and Kansas City, again, we've got open and union. Kansas City does a really amazing job. It pretty much mirrors the US national average. So from an average standpoint, currently in 2025, the rate is about 72 cents a square foot installed. And then we're going to go to a very low labor market, being Dallas, and you can see it's below 50 cents. So it's about 48 cents a square foot for a union job. And when you get down to non-union, you're about 37 cents, below 40 cents a square foot. And then we look at national average, you can see again that Kansas City is kind of right there in the middle basically plotting right at national average for union and actually for non-union as well. So when we look at these labor rates, the next thing we want to talk about is, how do these labor rates translate into the overall cost of building a wall? And you can see on this chart, this is looking at non-union jobs. So we're looking at kind of worst case situation where the labor rate is going to be the lowest percentage. And, from a national standpoint, labor represents 48% of the installed cost of a wall. And you can see, Dallas having a lower labor rate is about 42% versus New York with a higher labor rate, which is 62%. So, somewhere, 50% plus or minus 10 is really what your labor component is in building these walls. So how do we build these walls? So let's start with another polling question of what is your go-to method for building STC-rated walls? Is it multi-layers of gypsum? Is it decoupling using like resilient channels or clips? Are you using insulation as your sole source? Or are you using QuietRock or some other CLD panel? Or do you have another situation, the catch-all? So let us know what your go-to is. Just about ready there with that one.
Yes, so 15% says multi-layers of drywall, 54% for decoupling, 15% insulation, 8% QuietRock or other CLD panel, and 8% other.
Okay, great. So good spread. And for those of you that are other than the 8% using a CLD panel, I'm going to blow your mind in the next couple slides. So let's first look at some different methods. So I tend to look at these methods as kind of a knife, fork, spoon approach because, they're all different. You can use one tool or the other, or you can mix and match. Sometimes you need to have a spoon and a fork to eat a meal, or sometimes you need the knife. So let's go through all these methods. So mass, as you know, is it's very effective at low frequencies. The problem with mass is it's got diminishing effectiveness. So as you add layers of drywall, the first layer is going to give you the most benefit. The second layer is going to give you less than the first. The third layer is going to give you less than the second. So it's not additive because sound is logarithmic. You're getting diminishing returns each time you add something to that wall. Mass law basically tells us that for every 4 points of STC improvement, you need to double the mass. So if you've got one layer on each side, doubling is 2 layers. You get 4 points. Double it again, now you went from 2 layers to 4 layers, you're going to get 4 points. Double it again, you go from 4 layers to 8 layers, you're still only going to get 4 points. So you end up with very thick walls, which adds to wasted floor space, and it adds a incremental labor and time because each layer needs to be added. If you're in a fire rated situation, each layer may need to be inspected separately by the building inspector. So a lot of additive issues with looking at mass. When we go to decoupling, decoupling was truly invented for a ceiling application initially, but it's transitioned to walls, and it remains pretty effective on very effective on ceilings. This process of decoupling works well with other methods, so it works well with mass, works well with CLD. It does add thickness to the wall, not to the degree that mass does, but it does add about a 1/2 inch to 1.5 inches depending on what type of decoupling method you're using. Decoupling can also mean staggering or double studding the wall. So if you're doing something like double stud wall, obviously you're adding about 4.5, 5 inches to the thickness of that wall just by adding another row of studs on a plate. Sometimes these systems can be very intricate and time-consuming installations, particularly if you're using clips that have to be precisely measured and installed separately. And if you're looking at things like resilient channel, those systems have a very high failure rate. There's a study done a number of years ago that suggests that about 90% of all resilient channel walls fail within 10 years. Various reasons for that, and I can go into that in a different course because we're chugging away on time here. But really look at the failure rate when you're looking at some of these decoupling methods. And the next one we're going to talk about is constrained layer damping. Again, this is QuietRock. So there's minimal or no additive thickness, basically because you're substituting out one layer of a constrained layer damp gypsum board, being QuietRock, for a layer of type X. So it's a one-to-one switch most often. This, again, works well with other systems. It can be added to a mass loaded wall. It can be added to a decoupled wall, or it can be used on its own. It's easily integrated in new construction and renovations. It's not effective for impact noise. So people always ask me, can I use it on a ceiling? Yes, it can be used on a ceiling, but it's probably not going to address your primary noise problem for the ceiling, which is usually footfall. And the other downside is it does have a high material cost. So people kind of do get sticker shock, and they don't look at the rest of the process when you're looking at creating a high STC wall. So again, from a material investment standpoint, mass is going to be kind of a low cost. Decoupling is kind of also a moderate cost, and the constrained layer damping, obviously from a material standpoint, is going to be much higher. Conversely, when we look at the labor impact, constrained layer damping is going to be your lowest labor impact on the wall cost. Separating that from decoupling, which is moderate to high depending on what you're doing, and also mass, which is kind of moderate to low because it's incremental for each layer that you're adding. From a space efficiency standpoint, mass is going to eat up a lot more space for each layer that you put on. Decoupling, it depends on what type of decoupling method you're going for, but it can eat up 1 inch to 4 to 6 inches if you're going with a staggered or double stud wall. And constrained layer damping doesn't add any thickness to the wall because, again, it's just a swap out of material. From a performance gain standpoint, again, this all depends on the entire wall system. It has nothing to do with product by product, STC calculations. STC is calculated by the assembly. So from an assembly standpoint, mass gives you a pretty low performance gain because it's incremental with each layer and it's diminishing returns with each layer. Decoupling gives you moderate gains. You're going to get 5 to 10 points depending on the assembly. And with constrained layer damping, again, moderate to high, you're going to get 5 to up to 15 points, again, depending on the assembly. And again, like I said, all these three methods can work together. So here's a couple of examples of a decoupled wall using a double wall. So it's decoupled one side from the other, and it has QuietRock on either side. And then the assembly on the bottom, I kind of call my everything wall. It's got mass on one side with 2 layers of drywall. It's got a resilient channel, and it's got QuietRock on the opposite side. Insulation. Now, a lot of you said that you do use insulation as your primary source of sound attenuation. The reality is insulation is a good component of a sound solution, but it's never going to be enough on its own. It needs to be employed with mass, constrained layer damping, QuietRock, or a decoupled system. Insulation is going to give you 2 to 4 STC points. It has its limits. What it's really doing is absorbing the amount of sound that's rattling around within that wall cavity. And obviously, the more sound bounces around in the cavity, the more ability it has to escape the cavity. So it is helping from that aspect, but it's not really contributing the heavy lifting that some of the other solutions have. The other reality of building a sound rated wall is you must seal the perimeter and the any penetrations. ASTM C919 tells us that we need to use acoustic sealant around the perimeter of the wall and any gypsum to non-gypsum joints, as well as any unbacked penetrations. So outlet boxes, plumbing fixtures, any of those things that you've got holes in the wall, you need to seal that stuff up because any gap is going to let the sound leak through. So let's go back and talk about framing a little bit really quickly. So the biggest drivers when we're looking at wood and steel, the biggest cost drivers is the raw material input and the production costs. Those account for 50 to 65% of the end cost to you. The next biggest cost would be tariffs, transportation, and fuel. So those are all going to range around 10 to 15%. So as those things fluctuate greatly, we see the material costs of steel and wood fluctuate to the same degree. So one of the ways that we can look at framing is, there is an option when you're looking at framing going from 16 on center, which is everybody's kind of go-to, to splitting that out and going 24 on center. Now, in this example, these are both using 33 mil studs. They're both 1 hour fire rated load bearing walls from U425. You can see the 16 on center gets you an STC 40, and at a national average union shop, that's going to run $10.28 a square foot to install. The 24-inch on center is going to give you an STC 52. So you've gained 12 STC points just by pushing the studs further apart, and you saved $1.20 a square foot to do that. So you've got a better wall from an acoustic standpoint for less cost, and it still meets your 1 hour load bearing fire requirements. Other configurations you can look at is, single, stagger, and double. Now, as you go from single to stagger to double, you're increasing your STC performance. You're going to go, 45 to 53 to 61. So increasing by chance 8 points with these differences here. And you can see that the price also goes up. Obviously, to achieve higher results and do more things to the wall, the cost per square foot is going to go up, but you're getting that benefit of those increased STC points by spending those additional dollars. We have another poll question for you. So what is the most challenging aspect of building an STC rated wall? So Tao, if you can open this poll up. So it's going to be, managing your material cost, managing your labor cost, managing the schedule, interpreting the design details, or something else. Okay, so what do we got here, Tao?
So 36% says managing material costs, 20% managing labor, and the rest, 44%, say interpreting design details.
Got it. Makes sense. Okay, a lot going on. So let's go in and talk about substitutions and how we're going to value engineer and what happens. So one of the biggest pitfalls of value engineering is, unlike fire ratings, where fire ratings give you min, maxes, and great flexibility, STC reports do not have any flexibility. So anytime there's a deviation from a tested wall assembly, so when you're value engineering, you want to swap, one thing for another, that means that entire wall test needs to be redone. You need to find a different wall assembly that fits the test, that fits the materials that you're looking at. The smallest of changes can have dramatic effects. So what has to happen in this situation, and I do see some common changes, the stud mill thickness, the stud spacing, or drywall products. So what happens? So you need to look at your direct material cost and what the changes to your direct materials do to your STC. Now, obviously, after you add your material cost, your installation labor, and any costs associated with schedule changes, look at your new install cost, look at your new STC performance, because any changes are going to give you a different wall. I mean, if your performance is still at target and you've got a less expensive wall, great, make the substitution. But most often what we see is we may or may not get one or both of those boxes ticked. So let's look at a couple of those examples. So, one of the misconceptions is that, double type X will get you the same results as a constrained layer or a QuietRock on an assembly. So in this case, we do have an STC 50 with a double stud, or I'm sorry, the double layer of gypsum on each side, but it's going to cost you $1.23 more to get there. Why is that? you're adding 2 layers of gypsum, which you can argue that the QuietRock is more expensive. So you've got some material costs that are going to be different. But the biggest thing is you've got labor costs involved. You're installing 4 layers of gypsum versus 2. And remember that those second layers require longer screws, so it takes a little bit more effort to get those second layers in. Another misconception is, spacing doesn't matter. I always install in 16, even though maybe the architect specified 24. So again, we're starting with that QuietRock wall at STC 52. Somebody decided to change the spacing to 16, but now we missed the STC target by 12 points. So we failed the STC, we ended up with a 40, and it cost us $1.20 more to get to that failure point. So we spent more money and got a lot less for it. So, do the analysis, make sure that we're looking at every component piece. Environmentally, more materials in means more trucks, more waste, and so on. I'm going to speed through this section because I know we're kind of running long a little bit, but we've got a couple different one project here, 2 different walls they were analyzing. At the end of the day, the QuietRock assembly used less trucks, less drywall screws, less waste going to the landfill, 64 days less time on your schedule. We decreased labor by 21.7%, and we increased the floor space. We had 333 square feet of recovered floor space, and for the property owner, at $8 a square foot of rentable space, that translated into $32,000 of annual revenue that he was able to increase his project by. So let's get into the cost of these different methods. So again, we're going to look at the same knife, fork, spoon approach. We're going to have our baseline assembly, our mass assembly, our decoupled assembly using resilient channel, and our constrained layer damp assembly using QuietRock on one side. Other than the drywall and the resilient channel, these assemblies are exactly the same. It's 33 mil studs, 24 on center with R13 insulation. Everything else is the same. So from an acoustic standpoint, they're all basically alike. The baseline obviously isn't. It's a 45, so we're gonna make that a sound rated wall. We've got a 50 for mass, 50 for decoupling, and the QuietRock comes in at 52. So relatively all the same. From a fire standpoint, obviously the mass is going to give you 2-hour rating, but most often we're seeing this in acoustically being installed for a 1-hour wall, not for the 2-hour wall. So we're going to treat these all as 1 hour because that's what our requirement is going to be. And look at the space efficiency. We can see that we're going to eat up a lot of space, and we're going to be creating much heavier walls in some cases. So cost. So we're going to look at the high labor market first. So you can see the QuietRock wall is going to run you about $12.64 a square foot. Those of you that are using mass, to get to that same point in a high labor market like New York, you're looking at installing that same level of performance for $15.11. So you're spending, almost was that $2 and change more for the mass wall, and the decoupled wall is going to cost you about $17.84. We look at Kansas City, same scenario. Obviously, the pricing is a little different, but the QuietRock wall is $875 versus the mass at $976 versus decoupled at $1143. And then even when we get to a very low labor market like Dallas, the QuietRock wall is coming in at $732 a square foot versus the mass at $795 and decoupled at $914. And if we want to look at national average, same story. I've run this same analysis for many different markets, and I'm always surprised because we just pull the numbers and report them, and these numbers are being pulled from RS Means construction data. This is the Q3 2025 data set, and I'm always pleasantly surprised that QuietRock always comes in less expensive, even though everybody gets the sticker shock from the material standpoint, but we always forget about the labor component. Now, another thing that's really important to look at, and another way to analyze these different wall types, is the concept of cost per STC point. So to calculate this out, what we want to do is we want to look at a baseline and look at two different targets. In this case, we're going to look at that STC-52 QuietRock wall that we've been looking at, and then that everything wall that we saw earlier. This one's an STC-58, so it's quite a bit higher performance. And you can see the installation costs, the baseline 777, the QuietRock at 908, and the everything wall coming in at 1462. Basically, what we're going to do is we're going to look at the deltas. So what is the change in STC? So 7 points for QuietRock, 13 for everything. What's the change in cost? $1.31 versus $6.85 for the everything. And then we're going to simply divide those. So you can see that the QuietRock wall comes in at 19 cents per STC point, and that everything wall comes in at 53 cents per STC point. And I would expect that to be higher because it's performing at a 58, which, as you go up the food chain as far as higher performing walls, you're going to be paying more for those STC points because they're going to get incrementally harder to achieve. So let's plot this on those 4 walls we've been looking at earlier. So we look at mass, and we're coming in at 51 cents a square foot to get to an STC 50 and that 5 STC point change. For decoupling, 85 cents per STC point. Again, the QuietRock is 19 and that everything wall is 53. And I thought it was kind of funny that that everything wall getting you all the way up to 58. Obviously, it's a 13-point change, but you're still getting that relatively less expensive than even like the mass wall at 51 versus 53. But this is a tool that's really good at analyzing like systems. So the everything wall is just there for fun, but really the true comparison is looking at these 50 and 52 assemblies, that the mass decoupling and the QuietRock wall, because that gives you the true picture of what the true cost for all those incremental STC points would be. So in summing this all up, finding the true value of an acoustic system is, looking at your substitutions and making sure that they're economically appropriate. That they tick both boxes. They have to be less expensive for materials and labor once it's installed, and it has to also comply with the STC requirements. And any changes from an original design is going to require a reanalysis of the STC performance to make sure that you're still ticking the boxes on the STC tests. Remember that materials are only one part of only one component. They're a piece of the puzzle. I've got one of my colleagues likes to say that you don't go out and buy a car because of the price of the tires. You buy the car because of the entirety of that car, what performance and what goals that car gives you. So don't get hung up on one piece of the puzzle. You have to treat this as an entire solution. And then don't overlook the related costs. What are the costs of handling multiple layers of product on a job site? What are the costs of disposing of the waste? All those things add up, and we tend to overlook all those related things. And then lastly, calculate that cost per STC point. It's going to be eye-opening, and you'll find pretty quickly that assertions and assumptions that you did make may not actually be valid. So go out and do the math for yourself. Take a look at what makes the most sense. And with that, I want to thank you for spending the last 30 plus minutes with me talking about this, and we'll open this up for questions. And as you can see on this slide too, I've got a QR code with a link to our sound design guide. So in our sound design guide, we've got over 200 tested wall assemblies of various types, steel, wood, single, staggered, double, you name it. We also have a good intro to STC and sound, and we've got a section on fire control and fire resistance and how all that can get married together. So I invite you to take a look at that and download that guide. And with that, we'll start with some questions.
All right, thank you, Mike. We have a couple here. Starting off, is QuietRock readily available and where can I get it?
Great, yeah, so QuietRock is distributed throughout North America. We rail it to several of our reloads that we have throughout Canada and the US, and then from there, you know, your normal gypsum dealers will carry it. We stock in multiple yards, multiple different distributors throughout the country. You can go to our website. We have a where to buy button, and you can plug in your zip code and you can find the closest dealer to you.
Thank you. Next question. I have a wall design that calls out STC 50 lab over 45 field. What does this mean?
Got it. Yeah. So the building code specifies that you have to have a lab test of 50 or a field test of 45. So what that means is it's basically the one in the same wall. So if you've got a lab test of 50, it kind of gives you a 5-point leeway because there will be issues in building that wall in the field. You'll have flanking issues. You'll have different things going on in that wall that just aren't there in the lab. You'll have penetrations. You'll have joints. You'll have windows, whatnot. So it gives you that flexibility to make sure that you can actually build that wall according to the building code. Thanks for that.
When a design professional specifies steel thicknesses greater than 30 mils, what resources, if any, does a contractor have to determine the effect on the STC?
Yes, so you're gonna have to, so there's a couple of things in this question I want to address. So first of all, the industry a couple of years ago moved from talking gauge to talking mil thickness. The reason for that is gauge is really kind of a classification. It's really not a true measurement. So if you look at like 20 gauge can mean anything from 18 mil to 33 mil, depending on the strength of the stud. So so from acoustic standpoint, mil thickness is way more important than gauge. So distinction there. So everybody needs to get the mil thickness mindset. Now, when you get into thicker mil thicknesses, like you said, above 33, which is like a 20 gauge construction grade or structural grade, when you get beyond that into 54 mil, 96 mil, you're going to need to look at different resources. Now, we do have those tests, a lot of those tests in our sound design guide. We do have those thicker stud gauges, and you're right to look for that information, because as the studs get thicker, it is much harder to achieve those higher STC ratings. So you'll see much more complex walls with those thicker stud types to achieve an STC 50, 55, 60. Thanks for that.
Yep. Next question, will the standard QuietRock ES offering eventually be phased out by its MR variant, being it's the same price?
In different markets, that is the reality. But there are markets in the US that really like to have the option of both, with or without the MR included. So it's going to be market by market, but I don't have any plans right now to phase the standard product out. But one of the good things about having MR in the reloads is you can always turn, MR can always be used in the standard situation, but a standard cannot be used as MR. So for that reason, you may see more MR stocked than standard at some of our reload locations.
And next question, where can I find more acoustic tests so I can see what my options are?
Great. So yeah, check out our sound design guide. Also check out our website. We do have a assembly builder tool on the website where you can plug in some of your knowns, and it'll basically filter the designs that we have in our design guide and give you a filtered result set. So and allow you to download some data on that and instructions and so forth. Beyond that, if there's something that's not in the design guide, give us a call. Call our 800 number, shoot us off an email at info@QuietRock.com. We have a very extensive testing library. We've done probably over 2,000 acoustic tests now in the last 5 or 10 years. And we've got a ton of data. We've got much more data, many more assemblies than we could possibly publish in a design guide. So, hit us up. There's a chance that we may have one of those unique assemblies that we have not published in the guide.
Well, that concludes our Q&A portion, Mike. So I'll send it back to you for some closing remarks.
Great. Thank you all for attending. It's been great to chat with you about the economics of these STC-rated walls. They are a complex situation. They're very unique, unlike other things that you build. And they do take a little extra time and effort to really figure out what they're all about. So again, thanks for the time. And if you have any questions, any follow-up questions, please don't hesitate to hit me up. My email address is on the screen, my cell phone number. And again, our website is www.pabcogypsum.com, and you can find the QuietRock page on the website and find a ton more information about QuietRock and our products and different alternative solutions. So again, thanks for attending.
Yes, thank you so much, Mike. Thank you to our sponsor, PABCO, and thank you everyone for attending. We'll see you next time. Bye now.
Bye, everybody.